The deep sea is a world of extremes, a place where life is pushed to its absolute limits. Over the course of this series, we've examined how creatures have adapted to survive in the cold, dark depths of the ocean. We've explored the diverse ecosystems that thrive in this hostile environment, where organisms cling to whatever energy sources they can find, whether it's the heat of hydrothermal vents or the remains of dead whales that have sunk to the ocean floor. Now, it's time to delve even deeper into the most enigmatic part of the ocean, where the abyss becomes truly unfathomable. This place is the Mariana Trench, the deepest part of the world's oceans, and a region filled with oddities that stretch the limits of what we understand about life on Earth. From faceless fish to sprawling fields of bacteria, and even gigantic creatures that resemble life from another planet, the Mariana Trench is a hidden world of extreme survival. The Mariana Trench is a crescent-shaped scar in the Pacific Ocean floor, stretching over 2,550 kilometers long and up to 69 kilometers wide. It plunges into a seemingly bottomless abyss, with its deepest point, the Challenger Deep, lying approximately 11,033 meters, or about 36,200 feet, below the surface. This abyss represents the lowest known point on Earth's surface. However, the Mariana Trench is not an isolated phenomenon. It is part of a global network of deep-sea trenches that crisscross the ocean floor, formed through a process called subduction. Subduction occurs when one tectonic plate is forced under another. In the case of the Mariana Trench, the western edge of the Pacific Plate was thrust beneath the smaller Mariana Plate to the west, creating this immense geological fracture. The movement of these plates not only created the trench but also spurred volcanic activity, giving rise to the Mariana Islands. The Mariana Trench plunges into an inhospitable part of the ocean known as the Hadal Zone. The name Hadal is derived from Hades, the ancient Greek god of the underworld, a fitting title for a region of eternal darkness, freezing cold waters, and immense pressure. The Hadal Zone is so forbidding that for much of human history, scientists believed it to be devoid of life, a place too hostile for even the hardiest of organisms. The pressure in the trench is over 1,000 times greater than the atmospheric pressure at sea level, and temperatures hover near freezing. Additionally, there is no sunlight to support photosynthesis, meaning that food is incredibly scarce. This abyssal realm was long considered an impossible frontier, a void where life could not exist and a place that humans would never reach. In the 19th century, however, scientists began to challenge the assumption that life could not survive in the deepest parts of the ocean. The turning point came in 1875 when the crew aboard the HMS Challenger embarked on a scientific voyage to map the ocean's depths. While exploring the Pacific Ocean, they encountered a surprising discovery. The crew lowered a weighted sounding rope to measure the depth of the ocean floor, only to find that they needed far more rope than expected. This was the first recorded discovery of the Mariana Trench, revealing that the ocean was far deeper than previously imagined. News of this discovery ignited a new wave of curiosity and exploration, setting the stage for future expeditions to the depths of the trench. Nearly a century after the HMS Challenger's discovery, two men made history by becoming the first humans to reach the bottom of the Mariana Trench. In 1960, Swiss oceanographer Jacques Picard and U.S. Navy Lieutenant Don Walsh descended to the Challenger Deep in the Bathyscaphe Trieste, a small submersible designed to withstand the crushing pressures of the deep sea. Their journey took nearly 5 hours, and the submersible's viewing window cracked under the immense pressure during the descent. Despite the dangers, Picard and Walsh spent about 20 minutes at the bottom of the trench, where they made a groundbreaking discovery: life existed in the deepest part of the ocean. Among the creatures they observed were pale shrimp-like animals and flounder-like fish, along with a dark brown, ooze-like substance that covered the seafloor. Picard described the moment with great excitement in his writings, as it confirmed what biologists had speculated for decades: life could indeed survive in the deepest depths of the ocean. More than 50 years later, in 2012, filmmaker and explorer James Cameron followed in the footsteps of Picard and Walsh. Aboard his custom-built submersible, the Deep-Sea Challenger, Cameron made a solo descent to the Challenger Deep. His dive revealed even more about the mysterious world at the bottom of the trench. Cameron observed microbial mats, strange, filamentous clumps of microorganisms living off chemicals from altered rocks deep in the trench. These microbes use a process known as chemosynthesis to produce energy, a method akin to photosynthesis but without sunlight. Instead, they rely on chemical reactions, particularly involving sulfur compounds, to generate energy in the pitch-black, nutrient-poor environment. These microbial communities form the foundation of the deep-sea food web, supporting more complex organisms that feed on them. In 1996, another landmark expedition shed light on the Mariana Trench's extreme ecosystem. The Japanese unmanned submersible Keiko reached a depth of 10,897 meters, the deepest dive by an unmanned vehicle at the time. Keiko's mission was to sample bacteria from the microbial mats that had been observed by previous explorers. The bacteria collected from the trench proved to be obligately barophilic, meaning they thrived under high pressure. This discovery overturned the assumption that life could only exist under moderate conditions, expanding our understanding of the resilience of life. But Keiko's exploration also revealed a more complex ecosystem at the bottom of the trench. In 1998, the submersible captured footage of a giant amphipod, a type of crustacean, measuring much larger than those found at shallower depths. This species, later identified as Hirandelia gigas, thrives in the extreme conditions of the trench, despite the challenges posed by the high pressure. The discovery of Hirandelia gigas raised many questions about how such creatures could survive in a place where most life forms would be crushed by the immense pressure. Amphipods typically possess calcium carbonate shells, which dissolve more easily in deep-sea environments due to the high pressure. Yet, Hirandelia gigas retains a tough exoskeleton, thanks to a unique adaptation. These amphipods extract aluminum ions from the seafloor mud and use them to fortify their shells, creating a form of aluminum armor that protects them from the harsh environment. This ability to extract and utilize aluminum from their surroundings is an incredible example of how life adapts to survive in even the most extreme conditions. Furthermore, as scavengers, or detrivores, these amphipods play a crucial role in the deep-sea ecosystem by breaking down organic matter, including wood that sinks to the seafloor. In addition to amphipods, other strange creatures inhabit the depths of the Mariana